Hi, in this video, we're going to talk about sketching log graph. So the basic form for log is y equal log a. So a the base. It could be any base, 2, 3, 4. In this case, a is about 2.71 of x. So before any transformation, the basic graph will look like this. So think about x here. You cannot have log of zero. So log will have the asymptote at x equals zero because log of zero is impossible. You can't reach that. Okay. And because the graph has to move along the asymptote, so it will look something like this. So now we're going to learn with all type of transformation how do the log graph will change. All right. So I'm going to delete this and we're going to start again. So let's say the general form for log equation is y equal log a, could be any base, of x minus h plus k. And you could have a dilation factor here, s n or something. Um, and is the dilation affecting the y value. So the first thing that you got to do is you going to find the asymptote. So the asymptote for log is the x value that make log of zero because log of zero is impossible. So technically to find the asymptote, you just need to let this equal zero. So x minus h equals zero. So you have x equal h. So if x equal h, the whole bracket will become zero, right? Now think about um, x equal h is one of the asymptote. So if you didn't have any reflection, so think about you have the positive in front of the log here, and also the positive in front of the x. So positive log a and then positive in front of the x. Your shape is just the most basic one. It's go like that. There's no reflection, right? Then if you do have a reflection. If you have a negative outside in front of the log, so think about this one become a negative and you'd have the positive inside. So negative log A of positive X. So with the negative outside is the reflections in the X-axis. So your shape will go this way now. Okay. Then we're going to change the side around. This time I'm going to have the positive outside and the negative inside. So positive log A of now I have the X become the negative. So this is a reflection in the y-axis. So think about the original goal like that. The y-axis will become this way. Okay. And finally, if you both have reflections, so if I have negative and then I have negative, my shape will do reflection in the x-axis and reflection in the y-axis. It will look like this. So you have four different type of um, log graph. All right, we're going to do some example together here. Here, so sketch log y equal 3 log a of 2x. So our first step is we find the asymptote. Okay, so to find the asymptote, which is whatever the x value inside log that make that equal 0. So 2x equals 0, when we divide it by 2, we still get 0. Okay. Then your shape. Um, so we do have x equals 0 here as the asymptote. There is no reflection, the positive and positive, which is the shape will be like that. So we will have something like this. All right. So they don't cut the x-intercept, the y-intercept, sorry, they only cut the x-intercept. So we're going to find that. So the x-intercept, you let y equal 0. So you're going to make y equal 0 here. So 0 equal 3 log a of 2x. Then you're going to solve for x. So there's a 3 here, so you're going to divide it by 3 on this side. 0 divided by 3 is 0 equal log a of 2x. Then you need to get rid of log a, and opposite of log a is exponential that. So you do a to the power, a to the power, a to the power log a will go away. So you end up having a to the power of 0, which is 1. So you have 1 equal to x, and then you solve for divided by 2, x equal 1 half. So you label this point as 1 half, comma 0, right? Okay, here I do have another example. Sketch two different type graph here. So I'm going to do A. Okay, so asymptote, as I say, is whatever the log inside, make that equal 0. The one is the translation. It does not affect the asymptote. So asymptote x minus 5 equals 0, x equals 5. So my shape will be, so I have x equal 5 here. Then I look at the side, so positive outside and positive in front of the x as well, no reflection. So my shape will look like that. I'm going to find the x-intercept here. So to find the x-intercept, I make y equal 0. So I would have log 2 of x minus 5 plus 1 equals 0. I move the 1 over, so log 2 of x minus 5 equal negative 1, right? Then to solve for um, x, I need to get rid of log 2. So I do 2 to the power, 2 to the power, 2 to the power log 2 will go away. So you end up having x minus 5 equal 2 to the power of negative 1, which is 1 over 2. Then you plus 5 over, so x equal 5.5. So you're going to write here as 5.5, comma 0. All right. For B, we're going to do the same thing for B. Okay, but this time they do have a reflections, a negative, so the shape will change around. Right. So here I will have x plus 4 equals 0. You would end up having x equal negative 4. So this time I do have a negative asymptote. So I might move my graph to this side. So here, so you have 0 here, negative 4. So this is the asymptote, okay? X equal negative 4. Now, the negative here, you can say, is the reflection in the x-axis. So the original go like that, reflection it go like that, okay? But we don't know where exactly the eye could go like that as well. So before we sketch, we're going to find the x and the y first before we do that. Um, so to find the, let's find the y-intercept first because it's easier. To find the y-intercept, we let x equal 0. So we have y equal negative log 3 of 0 plus 4. 0 plus 4 is 4. So we have negative log 3 of 4. You don't know the approximate solution for it, but you can sort of estimate it. Think about log 3 of 4. Log 3 of 3 will give you 1. Log 3 of 9 will give you 2 because 3 squared for 9. So log 3 of 4 will be closer to number 3 here. That will give you 1 point something. Okay, so and you have a negative, so you know that this answer is negative 1 point something. That's how you estimate it. All right, so I have here, I'm going to label the y-intercept here 0, negative log 3 of 4. So I know that my shape will go like this, roughly. Okay. Now then I find the x-intercept. So to find the x-intercept, I make y equal 0. I would have negative log 3 of x plus 4 equals 0. The negative, you can bring it over. So bring the negative over here. So that's it becomes 0. So carry up the negative. Now, log 3 of 4, sorry, log 3, to carry up log 3, you're going to do 3 to the power, the whole thing. So 3 to the power of log 3 go away. You would have x plus 4 equal 3 to the power of 0 equal 1. And then you move minus 4 over, 1 minus 4 gives you negative 3. So you have here, this is negative 3 comma 0. So now you can link them together. So it sort of looks something like this. All right. Here's the last example. Now sketch the graph of this. Here I do the same thing. Asymptote is equal 0, x plus 5 equals 0. So you will have x equal negative 5 is one of the asymptote. So x equal negative 5. And my shape, there's no reflections. I know my shape will go like that or like that. I don't know where that is, but they cut the x and the y. So we're going to find that. Okay. So to find the y-intercept, we let x equal 0. So we have y equal to log a of 0 plus 5 minus 3. 2 log a of 0 plus 5 is 5 minus 3, right? And then I'm going to find the x-intercept. So the x-intercept, I let y equal 0. So I would have 2 log a of x plus 5 minus 3 equals 0. I move the 3 over. So 2 log a of x plus 5 equals 3. Then I'm divided by 2. So x log 2 of x plus 5 equals 3 over 2. Okay. Then you need to get rid of log A, and opposite of log A is potential that. So A is the power something. So you would have F plus 5, all right, equal A is the power of 3 over 2. And then when you plus 5 over, and you bring the 5 over, you're going to do minus 5 on this side. So X equal that. So to you would have the X and the Y the set here at x equal 3 e to the power of 3 by 2 minus 5 and y equal log a of 5 minus 3. Now, how do we estimate this? This is a bit of a more challenging one because you have to know what is log a of 5. You could use a calculator, and if you think of a common sense, log a is 2.7 roughly. Okay, so log A of A is 1. 2.7 of 2.7 equal 1. 5 is a bit bigger than that. So log A of 5 is it's going to be 1 point something. I don't know what that is, but I know it's 1 point something. So 2 times 1 point something and then minus 3. Depend on whether it's bigger than 1.5, bigger than 1.5 or less than 1.5. So for this one, I would use a calculator for this. Let me go to the cast. It is opening. All right. So here we have if I go to my case, so if I estimate log A is here of 5, I would get 1.6. So it's slightly above 1.5. So we do 2 times log A of that. I could have just write ln of 5 minus 3. That will give me a positive number, 0.2 something. So I know that my y-intercept, okay, is here, 0 point something. So it's slightly above 0 here. So it's 0 to log A of 5 minus 3. Okay, so therefore, because the shape go like that, so for sure my x-intercept will be somewhere on the negative region, a to the power 3 or 2 minus 5 from 0. And there you go, you can link them together.